Hello everybody and welcome to the OneClass channel. My name is Shenaeze and I'm a second year student at McMaster University. I'm currently in the Life Science program and I want to minor in Environmental Science. Today we'll be going over some commonly asked mathematical questions, mainly just algebra, at both the high school and college and university levels. If you need some homework help or tutoring, check out the links in the description below and let's get started. So our first question is simplify 128 over 16. We can do this using two methods, the first one being long division and the second one being just reducing. So we're gonna do the second method first. So we're just gonna write down 128 over 16. So we need to think of a number that can be divided by 128 as well as by 16. And I think that number is 4. So take red and we divide each of them by 4. If we divide 128 by 4, we are left with 32. Let's see. Remember, whatever we do to the numerator, the top part, we have to do the denominator. So if we divide the top by 4, we have to divide the bottom by 4. We're left with 32 over 4. This can further be divided by 4 again. So divided by 4. Divided by 4, and we are left with 8 over 1. Or we can just write that down as 8. For our second method of solving this, we can use long division. So we put 128 and 16 at the outside. And think of how many times 16 can go in 128. So it can't, we're going to have to put zeros for our first one and our second one, because 16 times 8 is 128. We subtract 128 to see if we have any remainders left, and we don't, which means that is our answer. Our second question is, what is 2 to the power of 6? So I'm just going to write down 2 to the power of 6. And we have to remember that 2 is our base and 6 is our exponent. I'm just going to write that down. That is our exponent which basically means the base is being multiplied by itself by 6. So the base is being multiplied by itself to the exponents times. So in this case we have 2 being multiplied by itself 6 times. It's 2 times 2, that's 2 times, 3 times, 4 times, 5 times, and finally 6 times. What you can do is you can continue multiplying, so 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on, or you can group them together. So this is going to give you a 4, because 2 times 2 is 4. This is going to give you a 4, because 2 times 2 is 4, and lastly this is going to give you a 4. We can then multiply these with each other. So 4 times 4 we all know is 16. And move this down. Times 4. And 16 times 4 is 64. So our final answer is 64. So our third question asks us to expand x plus 2 cubed. So expression of x plus 2 cubed, or to the power of 3. So this is in condensed form. We can transform this into expanded form, which is x plus 2 times x plus 2 times x plus 2. And then we can continue on using the FOIL method with just the first 2 brackets. So our answer is going to be x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. 4 is x plus 2. We can further simplify this by adding the common terms. So it's going to equal x squared plus 4x plus 4. Plus 4x plus 4 and x plus 2. We can use the FOIL method again and multiply both the fractions again. Both the brackets again. So in that case, it's going to be x squared times x is x cubed. X squared times 2 is 2x squared. Moving on to our second term in the bracket, 4x times x is 4x squared. and 4x times 2 is 8x. Moving on to our last term in the bracket, so 4 times x is 4x, and 4 times 2 is 8. So now we're going to just add up all of the common terms. So that can be added up, and this can be added up. And our final answer is going to be x cubed plus 6x squared plus 12x plus 8. That is our final answer. Got the final answer correctly. I'm just going to look at their solution, their steps. So over here in this question, they ask us, it's question 4, I believe. They ask us, what are the quotient rules for exponents? So the quotient rules say that when you divide two exponents with the same base, that is important, the exponents end up minusing each other. So basically, the rules for that is base has to be same. And the exponents need to be dividing each other. So is if a raised to the power m is being divided by a raised to the power n, we can also write this as a to the power of m minus n. Okay? So maybe we can do an example. Of 2 to the power 6 over 2 to the power 4 can be 2 to the power 6 minus 4, which is 2 to the power 2. Which also equals 4. And if we would have done this the long way, just to prove it, 2 to the power of 6 is 64. And 2 to the power of 4 is 16. And when you divide 64 by 16, you get 4. So you could either do the very long and hard way, or you can just use the quotient rules for exponents and do it the easy way. We can do another example. So one that's a little bit more complicated is x to the power of 12 and y to the power of 13 is being divided by x to the power of 2 and y to the power of 8. So 12 minus 2, again this can also be written as x 12 minus 2, so x to the power of 12 minus 2 and y to the power of 13 minus 8, which would then equal to x to the power of 10 and y to the power of 8. And there you go. How to simplify negative exponents in fractions. So question 5 is how we simplify negative exponents in fractions. So basically, if you get a negative exponent on a fraction, you have to take the reciprocal of that fraction. So basically, what I'm saying is that if x is to the power of negative n as exponent, so a negative exponent, it is essentially equal to 1 over x to the power of the exponent. A lot of people still put in the negative. Once you take the reciprocal, it becomes a normal exponent. So for example, if it was x to the power of negative 2, that basically just means 1 over x to the power of 2. Okay? And also, if we're given two different equations, if we're getting two in a fraction and both of the numerator and the denominator is raised to the power of a negative exponent, then we do the same thing. X to the power of negative n over y to the power of negative m is the same. When we flip this over, essentially, this becomes, this becomes y to the power of m over x to the power of n. If you want to break this down, you have x to the power of negative n being divided by y to the power of negative m. This becomes 1 over x to the power of n being divided by 1 over y to the power of negative m. Which is then, when you change that to multiplication, take the reciprocal of this. So that becomes y to the power of m over 1, and that ends up being y to the power of m over x to the power of n. And that is basically how we got our answer. For given an example, like 4 to the power of negative 4, for example, this would become 1 over 4 to the power of 4, which is then 1 over 4 to the power of 4 is 256. If you put in your calculator or expand it and then multiply, it's essentially just going to be 4 times 4. 4 times 4 times 4 times 4. So 4 being multiplied 4 times. If we're given a question that has two numbers being raised to a negative exponent, for example, 2 to the power of negative 2 over 4 to the power of negative 3. This can be written as 4 to the power of 3 over 2 to the power of 2. Essentially this, the numerator becomes the denominator, and the denominator becomes the numerator with the positive exponents that is associated by each of them. That is associated with each of them. So this becomes 64 over 4. 4, which can then be simplified to 16. 6. To 16. As our final answer. How do we simplify negative exponents on fractions? It's kind of like the question that we just did, but a little bit different. Basically the same question over here, actually. So right over here, it's the exact same thing. So the negative exponents defined as the inverse or reciprocal that has been raised to positive opposite of the power. So that, and when you're given two fractions, like the denominator and numerator is both raised to the power of a negative exponent, they just become the opposite with a positive exponent. So the numerator becomes the denominator, and the denominator becomes the numerator with the positive exponents associated with them. So it's an interesting question. How do you find the exponential function f of x is equals to a of x from the given graph. So this graph provides us with some x coordinates, one being some coordinates, so one of them being 2 and 1 over 16. 1/16. So what we can do, this is our x and this is our y, is basically just plug in the coordinates into our function. It's that simple. So our f of x, or our y, will be 1 over 16 is equals to a raised to the power of x, and in our situation x is 2. Just get that. And now all we have to do is we just have to isolate and solve for a, because that is our unknown value or unknown variable. So what we can do to get rid of this square is we can square root each of the function, the graph. So go to the graph again. Square that. So basically a is equals to the square root of 1 over 16. The square root of 1 over 16 can also be written as the square root of 1 over the square root of 16, which can then be simplified to the square root of 1 is 1 and the square root of 16 is 4. So now we know that our a value is equals to 1 over 4. And we can input this into our equation. So f of x equals to our a value, which is 1 over 4 raised to the power of x. Now we can try this out with another point if we want. We can try it with our x being 1. So when we put in 1 for our x value, we get y is equals to 1 over 4, because the 1 raised to the power of 1 is 1 and 4 raised to the power of 1 is 4. So over here, if we look over here at 1, it is about a quarter. We can try it with x being 0, and 1 to the power of 0 is 1 and 4 to the power of 0 is 1. So our function x is equals to 0 would be 1, which is right over here. So that's how we know that this is correct. And that would be our final answer. Okay. This example, our question is, what is 3/4 of a number is 16? What is that number? So essentially, when we're asked this type of question, always remember to have a variable in mind, because that number you can set as your variable when you're solving, because you have to solve for that number. So 3/4 of a number, that a number is going to be a variable. I like to use x, but you can use any. It doesn't matter which one you use. So 3/4. You really have to read the question and see which what they're trying to say. So 3/4 of a number, which means 3/4 is being multiplied by a number which we don't know, so we're just going to label it as x, is 36, which means it equals to 36. So this, initially what our function or our thing to solve for is 3/4 x is equals to 36. Now all we just have to do, we have our equation, all we have to do is isolate for x, and isolate and solve for x. We can do that by multiplying 4 on each side to get rid of this 4 at the bottom. So whatever we do to one side, we have to do the other side times 4. That gets canceled out. We're left with 3x is equals to, in my calculator, 36 times 4 is 144. Now, to get rid of the 3 and get x alone, we can divide each side by 3. And we're left with, this gets canceled out. And we're left with x is equals to 144 divided by 3, which is 48. Now, we can try solving. We can always, it's good to verify your answer. So we can put in x in our equation that we have above over here and see if we get 36. So what we can do is 3 divided by 4 times it by your x value over here, which is 48. When we do that, we get 36, so we know that our x value is correct. That would be our final answer. So those are all the questions that we have for today. If you like this video, make sure to give it a like and subscribe to our channel. This was Shenaeze, and see you on